Welcome to our tutorial today, everyone, and what we're going to be looking at is called proof by contradiction. Now there's one main proof that we have to learn to use proof by contradiction, which is to prove that the square root of 2 is irrational. Now remember, irrational means that it cannot be written as a fraction. So to prove it by contradiction, we're going to assume that it can be written as a fraction. And if we assume that it can be written as a fraction, we're going to prove that assumption to be false. So we're going to contradict that assumption to show that the square root of 2 is irrational. So to start off with our proof here, okay, we're going to say that we're going to assume that the square root of 2 is rational. Now we have to consider what that means, okay? So we know that if a number is rational, we can say therefore the square root of 2 can be equal to a over b, where it can be written as a fraction a over b, where a and b are integers, which means they're elements of z, where b cannot be equal to 0 because we cannot divide by 0 in a fraction, and a and b can have no common factors. Okay, where a and b can have no common factors. Because if they had common factors, then a and b could be simplified further, which means it would be irrational. Okay, so again, these are our three properties. The square root of 2 is equal to a over b, where a and b are elements of z, so they're integers. B cannot be equal to 0, and a and b can have no common factors. So now we're going to take the equation we've just set up, which is we have the square root of 2 is equal to a over b. And I'm going to square both sides to try and get rid of that square root. So when I square both sides, I now have 2 is equal to a squared over b squared. And to try and get rid of my fraction here, I'm going to multiply both sides by b squared. And when I multiply both sides by b squared here, I get a squared is equal to 2b squared. Okay? Now, if a squared is equal to 2b squared, and we know that b is an integer, any integer multiplied by 2 shows that a is going to be an even number. So we can say, therefore, a is even because any integer times 2 is even. So if a is an even number, we can now say that a squared is going to be equal to we can say that a is going to be equal to 2 by any integer c, because it could be any even number. So we're introducing a new integer now called c. And again, what I'm going to do here to get it to match the above is I'm going to square both sides. So now I have a squared is equal to 4c squared, which is also equal to 2b squared because it's equal to a squared. So now I can say, therefore, that 4c squared is equal to 2b squared. I'm going to divide both sides by 2 here. Okay, sorry, he should have been a squared. So I'm going to divide both sides by 2. So then I'm going to get b squared is equal to 2c squared. Okay, which means b is also even. Okay, for the same reason that any integer multiplied by 2 is an even number. But if b is also even, then therefore a and b have a common factor of 2. Because any even number can be divisible by 2. And if a and b have a common factor of 2, it can be simplified, which means our original assumption that the square root of 2 is equal to a over b, where a and b have no common factors, is false. So therefore, square root of 2 cannot be equal to a over b, where there is no common factors. So therefore, square root of 2 is an irrational number. And that is our proof by contradiction. Okay, So take a minute here, guys, go back through this, make sure that we add each step into our notes, and then we can practice some questions. Thanks very much, everyone. Bye now.